Okay, everybody, now we're moving on to the cast diagram. Yeah. Who's seen the cast diagram before? Lockie, tell me about the cast diagram. What does it mean?
Well, where it has the name of the actual thing, that's where that particular thing will be positive.
Fantastic, okay. So, let's name some quadrants up as well before we start. We usually start here with 0 degrees, and we have 90 degrees. I'm using degrees instead of radians just at the moment, but we'll get to radians in a sec. 180 degrees. 270 degrees. How do we describe this quadrant here, the 0 to 90? It's the first quadrant. Okay, so that's our first quadrant there. Between 90 and 180, how do we describe that quadrant, do you think, Denyon? If that's the first one, logic would suggest that that is the second quadrant, correct. What about the next quadrant? The 180 to 270, Sarah. Third quadrant. Lost the D there. And obviously 270 to 360, back here again. That's the fourth quadrant. Now, as Lockie quite rightly said, that means all three trig ratios, sine, cos and tan, are positive in that first quadrant. Sine, S, okay, is where casts come from, C-A-S-T. Sine is positive in the second quadrant. Tan is positive in the third quadrant. Cosine is positive in the fourth quadrant. And it goes without saying that if sine's positive, the other two are negative. So, for example, in the second quadrant, cosine and tan would be negative. So, remember, we've got our radian equivalents there. So, 90 degrees is pi on 2. 180 is pi. 270 is 3 pi on 2. Okay. There's a cast diagram. Clear indication if you've seen that before, please. Most people have. Well done. All right. Now, let's move outside the first quadrant. Let's get rid of that for a moment. Remember we defined that point here, as I'll write it up again. That point there was cosine theta sine theta. Okay, so we know that distance there was sine theta, and that distance there was cosine theta. Now, let's look at this angle here, right round there. That angle right round there that I've just indicated is the angle of pi minus theta. Why? Because there's pi and there's theta, so that angle around there must be pi minus theta. Okay, so we're around to here now. Let's look at that point now. Okay, let's look at that point there. What's its coordinates? Well, its coordinates are still cosine and sine theta. Okay, but what has changed as far as sine is concerned? S-I-G-N, I mean, by that. What's that distance there? Is that positive or negative? Negative. Okay, so that's negative. What about that distance there? Is that negative or positive? Positive. Right. So you notice that sine theta is the same. Okay, it's positive there and positive there. But the cosine there, that distance there, is positive there, but negative there. That's why, if we go back to the cast diagram, we can see that cosine is negative in that second quadrant. But sine is still positive. Sine hasn't changed, it's still positive. Cosine, same distance but different sign, it's negative. Alright, so hence, sine of pi minus theta, that angle, it's still sine. Okay, it's still that same value. There it is. Cosine of pi minus theta is still cosine theta, but it's negative cosine theta because it's gone into the negatives that way. Now, why is tan negative? Because tan, there's a few reasons, but one logical way, connect it back to what we looked at before. Tan equals sine over cos. Okay, so if sine is positive and cosine is negative, what must tan be? What's a positive divided by a negative? Negative. Okay, so it stands to reason if you've got a positive sine value and a negative cosine value, because tan equals that divided by that, that one must be negative as well. So, see the pattern, connect it up with the cast diagram. Which of the three ratios in the second quadrant is positive? Joseph? Which of the three ratios there is positive in the second quadrant? Sine. See? Positive. The other two are negative. Let's move on to third quadrant. Here it is. Okay, now once again, a bit of repetition here, but stick with me. All right, that point there was defined as cosine theta, comma sine theta. Okay, now this angle that we're looking at now, okay, is going from here right, oops, sorry. It's going from here right round to here. Okay. That round to there, that's pi. Agree with me? Because pi is there. So do you agree with me if that to there is pi, that this angle here must be pi plus theta? Okay, so that big angle, I haven't drawn the curve bit very well, but that angle around there is pi plus theta. All right, and its coordinates there, at that point there, are also cosine theta, sine theta. Okay, there they are. Now, sine theta here was positive. Okay. What about sine theta here? Negative. Okay. So negative sine theta. Cosine theta here positive. Okay, across there. What about here? Negative. Okay. So in this third quadrant, both sine and cosine are negative. Now tan, being defined as sine divided by cos, yes, we're on our way. We're on our way. If sine and cos are both positive, are both negative, and we divide them, we get what for tan? Positive. Okay? Hence we get a positive tan value there. So, summary, third quadrant, sine negative, cosine negative, tan positive. Fourth quadrant. Okay. So, theta's there and theta's there. So, I'll try and do a bit of job this time with the marking the angle. So this angle here, right round to there, done better this time, that's going to be 2 pi right the way around minus theta. Okay, the angle is 2 pi minus theta. Look at that. Go through the same process. Our point there is defined as cosine theta, sine theta. Okay, sine theta, positive there. What about here? Negative. See that? That's sine theta. Down here, that's negative sine theta. So sine is negative. Cosine theta for our original angle is positive. Is it still positive? Yes, it is. Cosine positive. Tan being defined as sine divided by cos. Negative divided by positive. Negative. Okay. So there's our fourth quadrant rules. So let's look back. Third quadrant, second quadrant. Okay, whoops. So there's our cast diagram. Okay, and we developed how we got the rules in the second, third and fourth quadrant. There's the summary. Okay. Now, important to realise that that table is very handy, but it's not on the formula sheet or the information sheet at the end of the year. Okay. Once again, you can use patterns because you know second quadrant, sine's positive, the other are negative. Third quadrant, tan's positive, the other are negative. Fourth quadrant, cos is positive, the other two are negative. So you can sort of see what's going on. But they are handy little rules. And we're going to use those now to solve some problems. Angles, finding exact values. So I'll just pause this. All right, we've got our quadrant rules here. Okay, and we're going to use these. Now, it's important to try and identify here, and it's easier with degrees than with radians, believe me, but it's all right with radians as well. the first thing we need to identify is what quadrant this angle is in. Okay, so we're trying to find the exact value. Okay, when I mean exact values, I mean root 3 on 2 or root 2 and all that sort of stuff. The exact value for sine 150. So there's no calculator involved here. But first thing to do is identify what quadrant that's in. Okay, and we can always have, a little circle here ready to go. Okay, 0, 90, 180, 270. Okay, so we can quickly identify what quadrant is 150 in. Alice?
Second quadrant.
Okay, second quadrant. So, because we've identified a second quadrant, I'm looking at those rules. Now, when we use degrees, instead of using pi, we're going to use 180 because we've identified that pi and 180 are the same thing. So, I've got 9 little rules there. Okay, so I'm narrowing it down to the rule I want. It's second quadrant because it's 150 and it's sine. So I'm going to use that rule there. So I put a little asterisk next to it. That's the rule I'm after. Out of those 9 rules, it's sine, it's second quadrant. So I'm actually going to copy that rule down. But instead of using pi, I'm going to use 180 because I'm using degrees. We'll use pi when we start using radians. So, 2 steps. Identify the quadrant, write the rule down. Now I ask myself, what do I take away from 180 to get 150? Bailey? 30. So 30 is my theta. See? 30 is my theta. Equals sine 30. Now it's just a matter of, from memory or looking up page 300, what sine 30 is. And on page 300, Dom, sine 30 is half. Answer, 1/2. Done. We've got the exact value for sine 150. 3 steps. Identify the quadrant, identify the rule, find theta, read the table. That was 4 steps. Let's do another one. Okay, let's have a look at, let's go tan 300 degrees. Tan 300 degrees. Okay, let's go through the process again. Ebony, 300 degrees, what quadrant? Go back to my little diagram. 4th quadrant? Okay. Okay, so what rule am I after? I'm after 4th quadrant tan rule. There it is. Asterisk next to it. Now, once again, instead of using 2 pi, I'm going to use 360, same thing. So my rule that I'm using is tan 360 minus pi equals negative tan theta. So once I've identified my rule, I just copy it out. Just replacing 2 pi with 360 because it's a degrees question. What do I take away from 360, Bethany, to get 300? 60. So 60 becomes my theta. So that equals negative tan 60 because 60 is my theta. Last step. Daniel, according to page 300, what is tan 60? Root 3. Now we've got negative tan 60, so the answer is negative root 3. How's that? All right? Now we're going to do some using radians. A little bit harder. Same process. Here's where our fractions are going to catch us out, guys. Well, hopefully not. Who's good with fractions? No? Okay, we'll see how we go. So cosine... Actually, no, before I do that, oops, I'm going to just put our table back up. So we've always got that there handy. That's the advantage of this thing. I can cut and paste it. There it is. Okay, let's look at this one. It's cosine 5 pi on 4. All right, I'm going to draw a new circle up. It's not a very good circle. Let's do another one. Oops. Okay, so let's look at our 4 quadrants there. We've got 0. What's 90 degrees in pi? Will?
5 and 2.
Yep. Lockie, what's 180 degrees as pi, as radians? Pi. Okay, then we've got 3 pi on 2. Now, I mentioned fractions because here, where the hell does this fall? Okay. One way of doing this, pi on 4 is easier to do than some other ones. But, I can convert all these things, and I'll do it in red so you can see what I'm doing. Okay. I could actually rub out pi on 2. And pi on 2 is the same as 2 pi on 4. Okay, so that's 2 pi on 4. What would pi be as a fraction over 4?
4 pi over 4.
4 pi over 4. And 3 pi on 2 as, 6 pi on 4. So that's a little handy hint if you're a bit weak on fractions is to work out where this guy falls. Now convert it to that. Now it's a bit harder when it's pi on 3, I admit, but that's one way of doing it. That makes it easy to see. So clearly now, Jared, where does 5 pi on 4 fall? Into which quadrant? Third quadrant. Okay? Right, so third quadrant, let's write that down. We'll go back to the black pen. Hold on, let's put it down for a second. Third quadrant. So I'm now after the third quadrant rule that involves cosine. So it's that one there. I'll put the asterisk to the left-hand side of it. So let's write that rule down. Cosine theta plus pi equals negative cosine theta. Pausing the video. Okay. Now, fractions, fractions, fractions. What do we add to pi, which is 4 pi on 4? What do we add to that to get 5 pi on 4? Alistair. We've got to find out what we're going to add to pi to get 5 pi on 4. Pi on 4. So, I might be going through this a bit slowly, but it's important that I do, just to get it right. So, there we go. So, pi on 4 becomes my theta. So, it equals neg cosine pi on 4. Last step, Daniel, page 300. What's cosine 45 or pi on 4?
Take your root 2 over 2.
Root 2 over 2. Answer, neg root 2 on 2. Let's do one more. Let me see. Let's have a look at sine 7 pi on 10, 7 pi on 6. Actually, no, we'll go sine 7 pi on 6. Okay, paste in our rules. Okay. What quadrant is that going to be in? Well, we've got 0. Oops. We've got 0. What's pi? 180 as something over 6. 6 pi on 6. So, just doing that should give us a pretty good indication of what quadrant 7 pi on 6 is in. What do you think, Ashley? Third quadrant. Okay, so we're looking for third quadrant sine rule, which is that one there. So then we write it down. Sine pi plus theta equals negative sine theta. All right, if 6 pi and 6 is there, what are we going to be adding to 6 pi and 6 or pi to get 7 pi and 6, do you think? Ebony. What are we going to add to that, which is that, to get 7 pi and 6? Pi and 6, fantastic. So pi and 6 is now our theta equals negative sine pi on 6. So, Daniel, you're doing well looking at the table here. What's sine pi on 6? $30. Half. So it's negative 1/2. All right, I've done a few of these now. How are they looking? Pretty good. I want to do one more. Let's look at tan 13 pi on 6. This brings up an interesting point. Tan 13 pi on 6. Hold on a second. What's going on here? That's 0 here. Oops, hold on. That's 0 there. That's pi there, which is 6 pi on 6. Hey, 12 pi on 6 is all the way round. What's going on here? We've gone beyond our fourth quadrant. How are we going to cope with this? That's quadrant 1, 2, 3 and 4. 13 pi on 6. We're actually going around again. Aha, we're going around again. How much do we have to go around again to get to 13 pi on 6? One full lap of the oval is 12 pi on 6. What do we have to do to get to 13 pi on 6? Another pi on 6. So effectively, guys, ones that go over the full lap, ones that go beyond the fourth quadrant, is actually the same as just tan pi on 6. And then just read tan pi on 6. Daniel, tan pi on 6. Root 3 over 3. Answer. So, don't get tricked by the ones that go beyond the fourth quadrant. Okay? You just go around a second time and get the answer from there. Is that enough examples, guys?
Yeah.
All right. Stop.